var inte frågan också.
Nej, inte där.
Nej. Ja, det
Okej,
kan
gå till nästa sida.
So let us continue with the lesson a little bit.
37. Efter 37 finns inga svar. Om vi går in på kapiteltext, nästa grej, då finns det 38, 39.
Det är bara kolla.
So let me just, of course you know this, but let me write it. Construct A plus B plus C plus D. So, and then A, for example, is this vector. This is, for example, A, and this is your B, for example, and this is your C, and finally this is your D. So something like this. Of course, in the exam it is easier, so I will give them in the grid paper so you can just draw them very easily, okay? But assume that these four vectors are given to you and you're supposed to construct the sum of these four vectors, yes? So what you are going to do, well, I would recommend you to parallel transport all of them, even though you don't need to parallel transport the first one, but it would be a mess if I want to draw all the pictures inside each other, okay? So I will choose a point wherever you like to. And then I parallel transport this vector here. Hopefully I can make it right. So this would be this vector. So I draw it from this point. And for drawing B, I will take it and parallel transport it, but I will start from the tip of the first one. So for example, something like this. I will put it here if I can remember this point. My head, something like this. So yeah, so you understand what is going on. Yes, in practice, this is the way that you have to do it. And then I will parallel transport this vector, but at the starting from the end of the second one. So I will take this one and parallel transport it here. Yeah, that's unfortunate, but anyway, so let us just do it. It's here, for example, and this is vector C. And then finally, what I do, I parallel transport it from this one. So you know, parallel transport means being parallel and the same size. So something like this. Okay, something like that. And the first point that I started was here. The final point that I reached to is here. I have to connect these two vectors, these 2 points. Yes. And then put the tip of the arrow exactly at the final point. So this blue vector that you see here is the sum of these 4 vectors, yes? So I think it is for you. But then I want to talk about the new lesson today. So let me give it a title. So there is also another way to construct the sum of 2 vectors, especially in physics it would be important. And I saw that sometimes in the book they talk about it, or I saw some diagrams. That is called Parallelogram Method. Parallelogram Method. I myself prefer this method, but this is also good to know about this method. Okay. This is a little bit restrictive. So if I want to use parallelogram method, I have to add 2 vectors, find the answer, and then use that answer with another vector. So it is time consuming. You need to construct a lot of pictures. But in this way that I told you, we started to learn. You see here, even though I had 4 vectors, but it was not that hard. I just started parallel transporting them, and then I connected the initial point to the final point, and I put the tip of the arrow at the final point. But what is parallelogram? So what was the standard way? Do you remember? So if you have the standard way, the second vector should be drawn from the final point of the first vector. This is the standard way, okay? But sometimes it might happen that you have 2 vectors starting from the same point. It doesn't mean that you cannot add them if you don't know this new rule, because you know what to do. For example, if I want to add them, I keep one of them, I parallel transport them, and then add them. There's also another way. If you look at the picture, let me draw this here. So if you have this vector B, and if you have this vector A, if I ask you find the sum of these two vectors, what you do, you just parallel transport one of these vectors, say this one, and draw it from here. So it would be something like this. This would be also B. Then I will connect this point to that point. This becomes a vector. This is A plus B. But if you change the point of view, if I connect this point to this point as well, what would be this shape? Yes? What is this shape that you see here? It's a parallelogram. Yes? Why is that parallelogram? Because this one is not only parallel to this, but also equal in sides. It can be shown that if I have a quadrilateral in which two opposite sides are not only parallel, but also have the same lengths, then it becomes a parallelogram. Okay, but then you can find another rule. Instead of parallel transporting, people can say that, okay, if you see that you have two vectors in this form, starting from the same point, you can complete this parallelogram. How? By drawing a line parallel to this one and drawing another line from this tip parallel to this one. Wherever they intersect each other, you connect this point to this point and put the tip of the arrow here. You see, I'm just generating the same picture, so that is completely clear that this should also be A plus B. But this is called parallelogram method for adding two vectors. It is useful if you have the same initial point, but it is also useful theoretically. Yes. So, for example, if this is representing a force, assume that this is a mass, a heavy object, for example. Someone is pulling this object with this force in this direction. Someone stronger is pulling the same object in this direction with a bigger force. What you expect that it would be, this particle acts in a way as if this force is being acted on that. It will start actually, if it is initially at rest, it will start to move in this direction. It will accelerate in that direction with a force which is proportional to the length of the sum of these two vectors. Okay, so this you need to know theoretically. If I have two vectors starting from the same point, in this picture, if I ask you, what can I call this vector? You need to immediately realize this is vector A plus B. Yes, that's the only thing that you need to do. Is that clear? That's called the parallelogram. But you see that there is, if I want to use only parallelogram law to draw the sum of this, that would be troublesome. Yes, because I need to do it 2 by 2. So, for example, let me just do it here. For example, assume that I want to only use parallelogram law to add these 3 vectors. Then you'll see that I will be more or less in big trouble. What I need to do, for example, I parallel transport it here, then this becomes this vector. If I want to use parallelogram, I need to remember, where should I parallel transport it, here or here? In the initial point, yes. So I need to parallel transport it here if I want to use the parallelogram law. Then there is no third one yet. I have to construct the sum first, which becomes this vector, which is A plus B, and then parallel transport this one and put it here again, you see, and this becomes this vector. And then you need to forget about this. Let me clean it not to confuse you. And then what I need to do, I can clean this one, and then I add these 2 vectors using another parallelogram law. So what does it mean? It means that I need to, let me clean all these mess. We don't need them. Then I have to complete another parallelogram here. Meaning what? Meaning drawing a line parallel to this one, drawing a line parallel to this line. When they intersect, find this one and find this vector. Then this vector that you get is A plus B plus C. And then you see that this is a big trouble, yes? Every time you draw the vectors, clean them, and then make a new parallelogram to continue. This is much, much faster way of doing that. But it's very important to understand that if I give you a parallelogram, and if I give you this is a vector A, this is a vector B, immediately you should realize that this diagonal of this parallelogram plays the role of A plus B. Yes? This is something that you need to know. Okay. Now we want to go, we talked about vector addition, but now we want to talk about vector subtraction. So we want to learn how to subtract two vectors. And we want to make it very natural. Can you think, because of course I want to define how to subtract two vectors. Definitions doesn't need any, a definition doesn't need any reason for that, but there is a motivation behind why that definition is useful. So if I ask you, how do you define? Assume that I have two vectors. Let me write with black. So assume that we have two vectors, A and B. My goal is to define for you how to construct A minus B. Okay. Do you have any idea what is a natural way to define this construction? Usually, because you know, this is a new object in mathematics. So far, you have only working with numbers. Numbers is an object in mathematics, numbers, but these are vectors. And then I am defining operations with these new objects. So more or less, for mathematicians, if it is possible to follow the same ideas that they have already developed so far, it's always easier and better to stick to that to those ideas. For example, if I ask you, what is 5 minus 2? If I want to do it with numbers, because this subtraction is not independent. If you know what is the negative of a number, and if you know how to add two numbers, you can immediately define the subtraction in terms of negative sign and in terms of addition. Yes? How do you define it? Do you know? If I want to use addition instead of subtraction, how should I do it so that I get the same answer? Yes?
Minus 2 plus 5.
Yes, that's don't replace them. That's correct. Yes.
5 plus plus parentheses minus 2.
Minus 2. Yes, that's exactly one way. So by the way, this negative sign is different from this negative sign. You see, this negative sign is a negative of a number. This negative sign is an operation that I do with two numbers. This negative sign is a negative sign which is act on one number. So this means that, first of all, everybody agrees that this is the same answer. This is 3, that's also 3. Okay? This is the idea how to define the vector subtraction. Why this is a good idea? Because if I give you a vector, do you know what is minus b? Yes, if I give you a vector, do you know what's minus b?
It's the opposite direction.
Yeah, so you know about it. We already talked about what is the negative of a vector. So if a vector is given to you, negative of that vector is also known to you. And then you learn how to add two arrows, yes? So it means that if I want to define a minus b, one natural point to start is to define it in this way. A plus negative b. Okay? So let me write here. Vector subtraction. And then I will write this as the definition here. So if I give you two vectors, A and B, and if I ask you construct the difference of these two vectors, you do it in this way. You find negative of B first, and then you add A to the negative B. So that is the definition of how you need to subtract two vectors. Yes? For example, construct A minus B in each case. So for example, number one, I don't know. For example, assume that you have B, this is your A, and then this is your B. I want to subtract B from A. I want to construct A minus B. This means B subtracted from A. So what I need to do, I need to find minus B first. Okay, so but minus B is very easy, isn't it? So what you can do, minus B, you can just choose a point. Minus B should have the same length. It should be parallel to this one, but it should point in the opposite direction. So this arrow has another name. The name is minus B. So the first step, so I will draw with blue everything that I add. This is the original question. Two vectors are given to you. I have drawn them in black. And then whatever I want to add, I will add it with the blue line, okay? So if I want to construct A minus B for this picture, the first thing that you need to do is to draw minus B or imagine minus B in your head. It doesn't matter. And then forget about the names. You have this black arrow and you have this blue arrow. Add them, okay? Just as the normal addition. So how should I add these two vectors? We learned before. I parallel transport this to here, okay? So I take this minus B and parallel transport it here. The name of this one is also again minus B, it doesn't matter. And then, so forget about the names. You are adding the arrows, and that is the standard way of adding arrows, yes? This second one is being drawn from the tip of the first one. What I need to do, I need to connect the initial point to the final point, yes? And then put the arrow here. If I ask you what is this vector, you can give two names to it. One name is A plus minus B, but people doesn't write this complicated. They just simply write A minus. It's not clear. So if you want to calculate, yes, calculate is not a good word. If I want to construct this vector, the first thing that I do, I take the negative one of the other one, draw it, parallel transport it, and then add them instead of subtraction. That is the very simple lesson of vector subtraction. Is there any particular question here? Yes?
Well, I think you said you were like going to give some sort of like natural explanation to it, because I remember when you talked about adding vectors, you like gave real life examples, like if you have a force that's pulling this way and a force that's pulling that way, then it will go this way, A plus. Yeah, but how could you explain it in like a natural way, how you could visualize it?
Yes, Kim?
I was just like, if you talk about in a physics example, it's like friction and momentum. If you just draw opposite vectors, you get the same idea, like that there's a negative vector and a positive vector.
Yeah, because what I'm
so forward momentum.
So this can also be taught. Yes, he's saying something good. You see, if I want to say this is the bottle, okay, I want to push this bottle here, but there is a fraction below it. It's actually acting against me.
Oh.
This can be seen in two ways. Of course, this I can see it as addition. I would say that my force is in this direction, the friction force in this direction. They are being added together. But because the other one is pointing in this direction, it is resisting to me. But in another way, you can say that, okay, I have a force in this direction, friction is in that direction. I am subtracting them somehow. So this is why you see it's not that independent. The notion of subtraction of two vectors means addition of one vector to the opposite of the other vector.
Yes.
So there is nothing independent for subtraction actually. Yeah, I might find to. If I can find a better example, I will try to tell.
I mean, that works.
Yeah. But I mean, in physics, I wouldn't say this is subtraction, because in future you will see that, okay, I have a force, pushing force, and I have a friction force. I am still adding them. The reason that you see that the acceleration is not that high if there is no friction, because one of them is acting in one direction, the other one is acting in the other direction. And if I have one force, you see, this is vector addition again. If I have a force acting here, this is my force, for example, And this is a little bit lower friction force. So you write friction force, force of friction. Yes. Still, I am not subtracting them. I am adding them. Yes. But if I ask you what is the resultant force, you would say that, okay, I parallel transport this one from the tip of this one, so it becomes this vector. And then I will connect the initial point to the final point based on addition again. And then you see that now the resultant force is smaller than the force that I am applying because some part of it is being wasted by the friction force. So this is, I wouldn't say it's, if you think in physics, if you are going to think about the differences, then you will get confused about negative sign in the future. So in the Newton's law, you always add forces. But the point is that if one force is in one direction, the other force is in the other direction, the magnitudes are being subtracted. Even though still I am adding, it's a little bit complex. That's a good question, by the way. You see, I am not subtracting forces here. Okay, so this one is bigger one, this one is a smaller one, but you see the resultant force is smaller. Somehow we think that we are subtracting because I had something bigger and then the resultant is something smaller, so I think that I am taking something out of it. But in principle, I am adding two forces. The reason that the resultant force is smaller is not because I'm subtracting them, because one of them is acting in one direction, the other one is acting in the opposite direction. So if I add them, the resultant force becomes smaller. So this is why I'm saying that always. But so let me see what will happen. Okay. Let me give you another example here. So this is why working with forces, with vectors, is a little bit counterintuitive. So you might think that always a minus b should be smaller than a plus b, but in vectors, this is it might be the other way around. We will talk about that. Okay. So let me give you another picture. So number 2. So for, that was my example actually. So let me just draw it. So it is A, and this is B. Yes. Okay, so we want to, let me write B below it, okay? So if I want to add them, you know how to do. I can do both of them in one picture. So let me review our lesson. If I ask you to add these two vectors, what you are supposed to do? For example, if you want to add, for the time being, I'm adding them. I will take this one and draw parallel transport it from here, yes? So this would be this vector. Okay, and then when I add them, this vector from here to here, this one is a plus b. Understandable? I am just adding them. Now let me subtract them. Let me construct a minus b. For a minus b, I have to do something else. Let me change my color. For minus b, a minus b, first of all, I need to construct the opposite arrow for b, which is this vector. Agree? Then forget about the names, add them again. Okay? I parallel transport it here and put it here. This is minus b again. Forget about the names. You want to add this black row to this red row. So black arrow to this red arrow. So you need to start from here up to here. And then this is a good example. You see it here. What is the name of this longer arrow now? A minus b. And you see this is a little bit counterintuitive, isn't it? Because a minus b is longer than a plus b.
That is strange.
Yeah. So this is why I want to learn. This is a very important thing in vectors. Don't get confused. Vector is a quantity with 3 properties: a slope, direction, and magnitude. So counterintuitive things can happen. So this is not a miracle. Yes, this is exactly according to what you learned. So don't get confused. This vector, this blue vector that you see here, is a plus b. And then this red one that you see here is a minus b, and then it is transparent that this red one is much longer, than the blue one. So be careful about these counterintuitive ideas when you are dealing with vectors. Is that clear? Yes or no?
Yes.
Okay. Now, I want to teach you another trick. It's also good for subtraction.
Technically, it's a bunch of small vectors where we
Okay. So let us do this. Let me ask you this. If I have this vector, let me ask you this. If I have a vector AB, for 2 points A and B, can I write it in this way? AO plus OB. Yes? Do you agree with this one?
Yes.
This is the shall rule. You even don't need a diagram for this. Yes? I am asking you, is this a true identity? You might say that let me draw the picture, but you'll learn that for this particular case at least, you don't need to draw a picture because you see the common point between these two, and I am adding them. So in my head, according to the Shall's rule, I can just eliminate them and write AB. So that's true. Yes? But you also learn something more to do this. Do you agree that I can write this exactly like this? Yes, because you also learn something else. Do you remember? If I told you that if you interchange them, you need to apply an extra negative sign. It's not like segments; they are directed segments. So if I change B and O, I have to apply a negative sign. Is that right? So then, so you can write it as AO minus BO. Now we learned about vector subtraction. Yes? This is why I am using this. I couldn't use this before because we didn't know about vector subtraction before. Let me see what was my point to bring this up. You can. So let me see why I did want to talk about this. Okay, so this is not wrong, but I didn't want to say this. Let me write this one for you. So let me write OB minus OA. Okay, so let me simplify this expression for you. So forget about this. That is not something wrong, but this is irrelevant. Okay, let us concentrate. I have 3 points, O, A, and B. I am asking you, if possible, try to simplify this as much as possible. Okay, so the first thing that you learn today is about vector subtraction. I have a vector here minus another vector. This is today's lesson. We learn how to deal with this. We learn that I write addition instead of subtraction, and the price that I have to pay is to put a negative sign here. Yes, this is what we learned today. But we also learned something in the previous lesson. How can I get rid of this negative sign? I can eliminate this, but the price that I have to pay is to interchange these two. Yes? So what happens? It becomes OB. This becomes plus. Instead of this negative, I write what? A. But then we can interchange them because of commutativity, yes? So I can write AO first, and then I can write OB. And now I can use the Shall rule, yes? Because this is addition, and the letter in between is the in common. So I can eliminate this and then write AB. Yes? So here, what we got is a very useful relation. So AB can be written as OA minus OB. This is valid for any points A, B, and O. But I want to get something out of it which is also useful. Now let me draw a picture. First of all, do you understand what's going on? It was a very simple calculation. Yes, you might say, why are you interested in this calculation? I will tell you the motivation. Yes?
Does this mean when you see OA minus OB, you can just write it's equal to AB?
Yeah, exactly. Okay, exactly. That's the what I want to show. But now let me draw the picture for this. Assume that I have 3 points, O, A, B. Any 3 points that you like. Because there is no limitation for the points that I will have to choose. You see, it doesn't matter which points I have chosen. This calculation will go. But now let us interpret this in the diagram. AB, so let me write, OA is this vector. OA is this vector. And OB is this vector. Okay, so OA is that vector and OB is that vector. But what is vector AB? Vector AB is this vector. But AB is OA minus OB. So we find another way which is simpler to draw the subtraction of two vectors. You see, it was not good for addition because in addition we get used to draw the second one from the tip of the first one. But for subtraction, there is a very nice rule. If I have two vectors starting from the same common point, if I want to subtract this arrow, if I want to write OA minus OB, there is a very simple rule. Just connect the endpoints, but remember, you have to put the tip of the arrow on the vector which contains the negative sign. Okay? So this is a very, very important rule. So you need to am I done something wrong? It should be wrong. Because you are not. No, I have made a mistake somewhere that I cannot detect.
But what is wrong?
Yeah, this one is wrong.
No.
Yes. You see, this is OB minus OA. Sorry. This is not OB. Yeah, please do not follow me exactly what I write. Please tell me, okay? So okay. OB minus OA. Were you discussing this? Okay, you should say it to me, okay? So I have written it correctly here, but when I want to write it in a box, I write it the other way around. Okay, so that is wrong, sorry. So this becomes OB minus OA. So because I knew the rule, it was not working. The rule is the other way around.
It's okay, Baba.
It's OB minus OA. OB minus OA is A. Now this is correct. Yes, that's correct. Okay, let me just remind you. So it was a mess here. So let me say, assume that 3 points are given to you, O, A, and B. They can be wherever they like. But let me just calculate this one for you. You might say, why are you interested in this calculation? I haven't finished yet. I will explain why. Let us just follow the calculation. I put equality. Instead of OB, I copy and paste OB. But because we learned what is the meaning of vector subtraction, this means exactly right addition. And the price that you have to pay is to put a negative sign for the second vector. Okay? And then OB is the same OB. And instead of negative OA, you can write AO. And then I interchange this one and write AO first and OB second. And then I use the shall rule, it becomes AB. So it means that AB is equal to this expression. So this is what I should have put in this box. This is the correct version. And now what I am doing, I am just drawing a diagram for you for this relation. So I choose 3 points, O, A, B, wherever that I like. And then I find the vector OB. What is vector OB? It means this is the vector OB. I find the vector OA, and I find the vector AB. According to what I have shown here, that diagram should be a correct diagram, yes? So it means that if you want to calculate OB minus OA, there is also a shortcut to it. If the arrows are being drawn from the same point, what you need to do, you need to connect the final points, but you need to be careful where to put the tip of the arrow. The tip of the arrow will be pointing to the point without a negative sign. You see, B doesn't have any negative sign behind it, so you need to remember to put the arrow, the tip of the arrow here, not there, because it would be wrong. Is that understandable? So, for example, if I ask you to draw, so for example, if I give you these 2 vectors, and I ask you to construct A minus B, you have 2 ways to do it. That is up to you which one you want to choose. One way was to draw the negative B, yes. First draw the negative B, yes, and then parallel transport it here, and this becomes again negative B, and then add them. So this becomes A minus B. This is one way of constructing A minus B. Another constructing way is to what? To parallel transport the same vector, not its negative, but not from the tip of this vector, from the initial point of this vector. See, I take this one and put it here. This is not minus B, this is B itself, but you need to connect these 2 points together and put the arrow on which vector? The vector containing the positive sign. So I need to put the tip of the arrow here. So this one is also A minus B. And then hopefully, if I draw this diagram very carefully, you really can confirm that these 2 have the same lengths, and they have the same direction, and they are parallel. So you see, for subtracting 2 vectors, there are 2 ways. I want you to learn both of them, even though in the exam you can choose which one you like. But it doesn't mean that I can just learn one of them, the other one is not useful. The other one is also very useful to learn. So is that clear or not?
Yeah.
Yes? Yes. So let me repeat that one together. So let me repeat this again. I have 2 vectors, vector A and vector B. I want to construct A minus B. 2 methods. The first method is to construct minus B first, and then parallel transport it, and then add these 2 vectors. Forget about the names. I have a blue arrow, I have a red arrow, I want to add them. So I take this one, put it at the end of this, parallel transport it here. It becomes negative B. Forget about the names. I am supposed to add the blue one with this dotted red one. You know what to do. You connect these 2 and put the tip of the arrow here. This vector that you construct is called A minus B. There is another name for this one as well. This is called A plus minus B. But nobody writes A plus minus B because there is a simpler way to write. That's A minus B. This is one way of constructing the subtraction of 2 vectors. There is another one that I proved here for you. Okay? What is the other way? The other way is that just parallel transport this without changing anything. But instead of drawing it from the tip of this one, draw it from the initial point. So I will take this one and put it here. This is not minus B. This is B itself. Okay? And then connect the final points together. So this is the final point, this is the final point. So then I have to put this tip of the arrow somewhere. This you need to be careful. There are 2 points that you can put the tip of the arrow, either here or there. How you need to understand, you need to see which one has the positive sign. The positive sign, A has the positive sign. So I have to put the tip of the arrow here. And this is also A minus B. 2 ways of constructing. You might say this is not the same line, but don't get confused. They are not the same lines, but they are the same vectors. Why? Because they are parallel, they are pointing to the same direction, and they have the same lengths. Yes? So this is why these 2 vectors are the same. So these 2 ways I want you to learn. It's up to you which one you choose in the exam, but it is important to know both of them. Later, at least, it becomes very important. Is that clear? Yes. So that is also one way to do that. Now there is another, there is a very interesting diagram, very important one. I want you to learn that. So tell me, what is this one? If I have this vector B here, and if I have this vector A starting from here, okay? Now let me complete the parallelogram. Yes? If I complete the parallelogram here, by completing means I will draw a parallel line to this from this tip. I will draw a parallel line to this from this tip. They will intersect at some point. Now let me ask you, do you remember what I told just a few moments ago? What is the name of this vector? A plus B. This is A plus B. We learned about that. But now we learn something new. We also learned that there is a name for this diameter as well. Okay? So what is the name of this vector if I put the tip of the arrow here? A minus B, you were supposed to, that's A minus B. This is a very nice diagram to have it in your mind when you are working with vectors. So if you have a parallelogram, okay, such that these 2 edges are vectors with the same point, one diagonal is A plus B, the other diagonal is A minus B. It's very, very important in the future, especially if you remember this picture. Okay? And then, for example, and you know that in rectangle, the diagonals have the same sizes, but in the parallelogram, this is not in general true. Yes? For example, here, the blue one is shorter than this red one. Is that understandable? Okay, but this is not a necessity, yes, because might be I have this situation. So, for example, I have a vector here, B. I can have my vector A here. This is my vector A. Let me complete this parallelogram as well. So if I complete it, how should I complete this parallelogram? I draw a line parallel to this one. From the tip here, I draw a line parallel to this one. Yes? And then let me ask you, this is the complete parallelogram. If I just connect this vector, this point to this point, what is the name of this blue arrow? Again, A plus B. Yes? But what is the name of this red arrow? Where is red one?
Yeah.
Oh, thank you. So this is the name of the, if I put the tip of the arrow here, what is this one? A minus B. Another counterintuitive picture. You see here the length of the subtraction is longer, yes, than the length of this addition. So, but this is a very nice diagram. When you're dealing with vectors, you should have this in mind. If I have a parallelogram with 2 vectors adjacent sides, one diagonal is A plus B, the other diagonal is A minus B. Is that clear? Yeah.
I know if this is relevant, but if you were to switch the way they point in the blue and the red, what would it be then?
So you can answer that yourself. Yeah. He's asking this question. If instead of putting this arrow, this point here, let me put here, something like this. Then the red one with this tip is called what?
So minus a plus b in
Yes,
parentheses.
that's correct. So it's minus a minus plus b. And then we learn that I can distribute this negative sign here.
Yes, Mick.
So this is the name of this vector. Yes, and if I put this one here, what would be the name of this one then? It would be minus a minus b, but if I multiply negative sign inside, we'll learn about that. This becomes negative a plus b, or if you want, you can write b minus a. But they are actually related. Yes, this is that's a good question. So this is why it's very important to know where to put the tip of the arrow. Otherwise, you are generating a wrong vector. Yes. That was a very good question. Thank you. So is that clear? Yeah. Okay. When we are going to end today, not that much. So let us stop here. I will stop here and we'll continue vectors next session. So you can now start working on the exam problems.
How much vectors is there? How many lessons do we have left on vectors?
I think because we will lose Monday for the exam, I think this Friday we will also work a little bit on vectors. Yeah, I think we will finalize next week on Wednesday.
Okay.
So how are we gonna solve it?
Let me end this stream. So there are 5 people online. I don't know if you are from a school or from somewhere else. Goodbye. Okay.
Goodbye. Get out. You need to be more charismatic. You need to like